All right, so what is up, amazing students, amazing people, and all the lovers of chemistry out there? I'm back again with yet another banger on this series on stoichiometry in chemistry. My name is David, and all I do here is take out the mystery from chemistry so chemi can make history. Today, we're looking at the concept of mass and mole relationships in chemical reactions. So, without wasting time, let's get into what we have for today. Let me start by saying stoichiometry basically is the foundation of quantitative chemistry. It allows us to determine how much of a substance is needed or produced in a chemical reaction. I will always make this reference to the recipe for a meal you want to cook. That recipe tells you how much of an ingredient you need to put or you need to add to get a particular result. In much the same way, stoichiometry tells you how much of an ingredient or a reactant in this case is needed to produce a particular effect in a chemical reaction. So in this part, we're going to be focusing on understanding stoichiometric coefficients. We're going to be understanding mass to mole conversions, and we're going to be understanding mass to mass conversions in chemical reactions. So sit back, relax, fasten your seatbelts, and let's get into what we have today. So let's talk about stoichiometric coefficients and their meaning. First, what are stoichiometric coefficients? Stoichiometric coefficients are the numbers in front of chemical formulas in a balanced equation. They represent the mole ratio of reactants and products in a reaction. Now look at this example. This is a chemical equation that shows the formation of water when hydrogen and oxygen combine together. Now you can see that there are not just letters in this equation, there are also numbers. Some are small and some are big. Now I want you to pay attention to the numbers that are big. You can see there is a big number 2 in front of hydrogen H2, and there's also a big number 2 in front of water 2H2O. Now, if you watch closely, you will see that these numbers are called the stoichiometric coefficients. They tell us that 2 moles of H2 or hydrogen reacts with 1 mole of oxygen or O2 to produce 2 moles of H2O or water. So the numbers 2, 1 and 2 that are standing in front of hydrogen, oxygen and water respectively, they are called stoichiometric coefficients. I hope it is clear. So your stoichiometric coefficients are the big numbers that are placed in front of chemical formulas in a balanced equation. All right, now, so what do they mean? First of all, they indicate the proportional relationship between substances. This means that if you double the amount of hydrogen, for instance, then that means you must also double the amount of O2, oxygen, and water. Next is that they allow us to convert between moles and between moles of different substances. Now, this is my favorite part. These stoichiometric coefficients allow you to convert between moles of different substances. Using the equation above, we can therefore say that 2 moles of hydrogen gives 2 moles of water. From the equation, you can see there are 2 moles of hydrogen there, and then 2 moles of water are produced. So that equation tells us that 2 moles of hydrogen are required to produce 2 moles of water. In the same way, that equation also tells us that 1 mole of oxygen is required to produce 2 moles there of water. I hope the explanation is clear. Now let's move on to the next concept we're looking at. We're looking at mole ratio. We've looked at moles. So what is mole ratio exactly? A mole ratio is the relationship that exists between reactants and products in a balanced equation. It is used for stoichiometric calculations. Now, let's see how this plays out. Using mole ratio, look at this equation on the left side of your screen. You can see methane, CH4, reacting with oxygen, O2, to produce carbon dioxide and water. Now, from this equation, using this mole ratio, we can see the following. First, 1 mole of methane or CH4 reacts with 2 moles of oxygen, O2. We can also say 1 mole of CH4 produces 1 mole of CO2 or carbon dioxide. 1 mole of CH4 or methane produces 2 moles of water, H2O. Now, even if these other ones that I am about to mention are not there, from the equation I can also see that 2 moles of oxygen produces 1 mole of carbon dioxide. I can also see 2 moles of oxygen produces 2 moles of water from this equation. So that's how mole ratios come into play. So now we're getting into the part where we get to solve some questions. Let's talk about mass to mole and mole to mass conversions. How do we convert from mass to moles, and how do we convert from number of moles to mass? That is what we want to look at in this point of this video. All right, now, so first of all, when you want to convert from mass to number of moles, you need a formula. And in this case, to convert from number of moles, all right, or to convert from mass to moles, this is what you do. You need three things. You need number of moles, you need molar mass, and you need mass. Now look at this formula. Number of moles on the right side of my screen is equal to mass in grams all over molar mass in grams per mole. Now here is this example. How many moles are there in 50 grams of sodium chloride, NaCl? Now, in this kind of question, definitely you'll be giving some details. You'll be giving the relative atomic masses of all the elements that are present in the chemical compound or in the chemical molecule. Now, look at this formula. We were asked to find the number of moles. How many moles are there? Number of moles is what we're looking for. So we are required to use this formula that says number of moles is equal to the mass all over the molar mass. Do we have the mass? Yes, we do. What is the mass? 50 grams. We've been given that. Do we have the molar mass? No. So what do we do? Let's go ahead and find it. So the solution says step 1. Let's calculate the molar mass of sodium chloride. To get this, we need to have the atomic masses of the elements present in sodium chloride, NaCl. That is, we have Na and Cl. That is the formula for the compound. Now, Na has the relative atomic mass of 22.94 grams per mole. So we have that there. And then chlorine has 35.5. So according to the formula, it is Na plus Cl. When we add the two of them together, they give us 58.44 grams per mole. That is the molecular or the molar mass now of sodium chloride, NaCl. So now we have the mass, we have the molar mass. We can now get the number of moles. Remember the formula, number of moles is mass divided by molar mass. What is the mass? 50. What is the molar mass? 58.44. So we simply say number of moles of NaCl is equal to 50 divided by 58.44. That gives us 0.856 moles. I hope that is clear. I hope that is clear. So converting from that's it for converting from mass to number of moles. Now, the next thing we want to talk about is converting from moles to mass. To convert from number of moles to mass, there is another formula we'll use. And that formula says mass is equal to the number of moles multiplied by the molar mass. In the first case, we said when you want to find number of moles, you simply say mass divided by molar mass. But in this case, when you want to find mass, you say number of moles times molar mass. Now look at this example. What is the mass of 3 moles of CO2 or carbon dioxide? In this case, they're asking us what is the mass, not what are the number of moles. So we are asked to find mass, and the formula says mass is equal to number of moles times molar mass. Do we have number of moles? Yes, 3 moles according to the question. Do we have molar mass? No. So let's go ahead and find the molar mass. So how do we find the molar mass? Now, the molar mass of CO2, remember the compound we're dealing with is carbon dioxide, CO2. CO2 contains one atom of carbon, which is 12 grams per mole. And CO2 also contains 2 atoms of oxygen, which is 16 grams per mole multiplied by 2. 16 multiplied by 2 gives us 32. When we add that to 12, we get 44 grams per mole. That is the molar mass. So now we can go ahead and use the formula mass is equal to number of moles multiplied by molar mass. So that gives us 3 multiplied by 44, and that ends us up with 132 grams of CO2. It's just so fun and easy. to understand. I hope you are following. All right, now, so the next step or the next thing we want to look at is mass to mass calculations in reactions. Mass to mass calculations help us determine how much of a reactant is needed or how much of a product will be produced in a reaction. So now there are some steps for mass to mass calculations. In this case, we're going to be using chemical equations that have been balanced. Step one, write the balanced equation. Step two, convert the mass of reactant to moles. Step three, use the mole ratio to find moles of desired substances. And then step four, convert moles back to mass. All these steps, we're going to be looking at them in depth, one after the other. So now look at this example. What is the mass? First question, what is the mass? So we are looking for mass. What is the mass of H2O or water produced when 10 grams of hydrogen reacts with excess oxygen or O2? Now, in this kind of questions, for every stoichiometry question you are asked to deal with, they will give you the relative atomic masses of all the elements that are concerned. Step one, remember we said this first step is to write the balanced equation. And by the way, if you do not know how to balance a chemical equation, I have a full playlist that has been made to tackle that problem from the beginning to the end. All the steps have been taken one after the other. So just do well to subscribe to this YouTube channel and check out all my playlists. I have a full playlist of how to balance chemical equations. So back to what we're talking about. We have the balanced equation written down here. The next step says convert grams of, let me not get ahead of myself. The next step says convert mass of reactant to moles. And the question says, what is the mass of H2O produced when 10 grams of hydrogen? Now we have 10 grams of hydrogen. We are required to convert it to moles. Now remember that formula we dealt with earlier on that says number of moles is equal to mass divided by molar mass. So now we're looking for number of moles, or we want to convert the mass of hydrogen into number of moles. So we have the mass 10 grams, but we don't have the molar mass of H2. So let's find the molar mass. H2 is comprised of two atoms of hydrogen, and one atom of hydrogen you can see from the detail here is 1.008 grams per mole. So when we multiply that by 2, because we have H2 there, so that simply says times 2. We have 2.016 grams per mole. Now, to convert it into number of moles, remember number of moles is equal to mass divided by molar mass. What is the mass? 10 grams. What is the molar mass? 2.016 grams per mole. So when we divide it, we have 4.96 moles. I hope you're following all the steps that I'm taking. Now, this step 3 says use the mole ratio to find moles of desired substance and then convert moles back to mass. So let's check out step 3. Step 3 says use mole ratio to find moles of H2O. Now, this is where the equation comes into play. The balanced equation has been written down. Now, from the equation, you can see that the elements that were mentioned, let's go back to the question to see. What is the mass of H2O? H2O is the first thing that our attention was pointed to. Produced when 10 grams of H2, hydrogen and water were the two um, points of concentration that we were given. So from the equation, you can see 2 moles of hydrogen were required to produce 2 moles of H2O. Now we have found the number of moles of hydrogen from that previous calculation that we did to be 4.96. So therefore 4.96 moles of hydrogen will produce, we don't know how many moles of water that will produce. So we just simply say X moles of H2O, which is water. Now this gives us an avenue that we can cross multiply. If we cross multiply, we'll say it becomes 2 multiplied by x being equal to 2 multiplied by 4.96. 2 multiplied by x gives us 2x. 2 multiplied by 4.96 gives us 9.92. So now we simply divide both sides by 2 in order to get x. When we do that, x moles of H2 now become 4.96 moles of H2O. Now we have found the number of moles of water that is produced. But the question says, what is the mass? Not what is the number of moles. So therefore, we need to convert number of moles to grams. Now, remember the formula to convert or to get mass is number of moles multiplied by molar mass. So now, let's find the molar mass of H2O, which is water. H2O gives us two atoms of hydrogen and one atom of oxygen. So in this case, H2 will be 1.008 times 2 plus one atom of oxygen, which is 16. That gives us 18.016 grams per mole. Now remember the formula. To get mass, we simply say mass is equal to number of moles times molar mass. What is the number of moles? We've calculated it to be 4.96. Molar mass is 18.016. So therefore, mass is equal to 4.96 times 18.016. That gives us 89.36 grams of H2O produced. So the final answer is 89.36 grams of water is produced when 10 grams of hydrogen reacts with excess oxygen. I hope it is clear. So in summary, for all we've been talking about since the beginning of this video, understanding stoichiometric coefficients, mass to mole conversions, and mass to mass calculations are essential for solving real-world chemistry problems. These principles are widely used in industrial chemistry, pharmaceuticals, and environmental science. So that's it for today's video. In the next video, we're going to be moving on to the next concepts in stoichiometry. All through this video, it's been nice being here with you. Thank you if you've stayed till the end of this video. My name is David, and once again, all I do here is take the mystery out of chemistry so chemi can make history. Till the next time I come your way, stay safe and be good. God bless.